Students, welcome to the lecture number 21. So, we have been discussing about artificial neural network. Today, we are going to talk more about that, and as well as we are going to discuss some interesting aspects of KNN, that is K nearest neighbor algorithm. So, of late, we are discussing about different machine learning algorithms, and as I said in the beginning of this course, one of the challenges of machine learning, utilizing machine learning in different branches of engineering is related to the development of new algorithms, and the algorithms which can actually be robust, which can provide you good accuracy, as well as they can be executed with a limited computational power and time. But KNN is one of the very challenging, important algorithms which has been used extensively in various kinds of problem solving. So, let us talk about that. So, classification algorithm is what we are talking about it of last so many lectures, and they are supervised learning methods. So, we talked about decision tree, we talked about support vector machine, then the last lecture I started discussing about NN. Today we are also going to discuss about KNN kind of things, and regression is already we have discussed. Okay, logical regression is not much different from the artificial neural network analogy. So, in a classification, we know we need to develop first a model constructions. When you have a set of data and which can be placed in a set of predetermined classes with certain attributes or features, what you need is basically a model for training, and that is a prerequisite to explain, or to rather to describe the nature of correlation among the data. And this model is represented as a classification rules. It can be defined by certain mathematical formulae, or it can be described by some decision tree or something. Okay. So, that is basically the basic part of the model descriptions. So, we are not talking about errors actually now, we will discuss separately for many kinds of error are involved, and for the machine learning we will talk about in a separate lecture. And finally, obviously once you develop a model, you need to validate it, and validation is something which is very important for any successful model to be applied or rather deployed. So, we are again going to discuss about the validation techniques and how it can be validated in a separate lecture. So, what about ANN? If you know that we have very good ability to identify any patterns with a very high degree of accuracy, that is one of the interesting feature of human. We can identify patterns very easily. Obviously, like if you see some object, like you see a car or a bicycle, you immediately can recognize the type. Why? Because you have learned over the time or period of time how a car looks like, how a bicycle looks like, how a truck looks like, how a boat looks like, and you can distinguish them. So, therefore, the moment you see that, you can easily distinguish them. How are you able to do that? Basically, you have a brain which can operate in a interesting manner or in an uncanny manner to distinguish the objects based on certain features. Artificial neural networks actually based on the similar kind of thoughts. They are computational systems that are intended to imitate human learning capabilities. How they do that? They do by a complex architecture. Well, I will not say very complex, they look like complex, but they are actually simple, and the architecture is basically based on human nervous system, the way human nervous system works. So, first thing I taught you how human nervous system works. Okay. As you see here, human brain is nothing but a parallel information systems, correct. What you have is basically something like a body, and these are the dendrites, okay. And then you have here at the end of oxygen you have synaptic naps, right. So, this is your nucleus, this is this action, and this is basically a nucleus, and these are the dendrites. So, this dendrites actually senses something, and then the cell, or basically this is called soma, with the nucleus, it processes the data, and then they are transmitted to this axon. Finally, at the end of the axon you have a synaptics nerves which are connected to another cell. So, it is basically a parallel information system. So, information is processed in nervous nerve cell and then it is passed on to the next nerve cell, and finally a output is given. When you are touching some hot body, you can feel it is hot. Why? Because of your nerves. The nerves can take care of the information from the hand or the fingers to the brain by this process, and this is a parallel system. So, and brain has humongous number of elements called neurons. This is what is called a neuron, and it is almost like a 10 billions of neurons. So, if I have to build a computational network using this concept of neuron, how do I do it? Well, at the top I shown you a biological neuron. See, this picture is much clearer now. You have dendrites and then you have a soma with a nucleus, action, and then you have the synaptic nerves. So, what you see here? The artificial network is exactly similar. You have input variables, these are inputs. These are inputs which are basically used to create. This is basically nothing but numbers, inputs x0 to xn or something. Then we have weights. So, we multiply this inputs with weights. That is what is done here, you see. So, therefore, dendrites are inputs here you see, and then you have weights. These weights are basically added, multiplied with the inputs, and then finally they are all added, you see here, and that addition is done in the processing elements, and after the addition you have something like a activation function transformation. We will talk about it detailed manner that way, and then we get an output. Remember, output is there are two types of output. One output is for each of these neurons, and finally there is an output at the end of the whole calculations. So, output of one single neuron is input to the next neuron. Same thing happens here also. So, neuron is connected to other neurons by synapses and it receives input from other neurons. So, basically what happens, inputs are combined. Once a neuron receives a signal, process it and feed it to the next neuron. So, what happens, inputs are combined and they are parallelly processed. Once the input exceeds a critical level, and we know the neuron discharges a spike, this is nothing but an electrical pulse, and it goes down the axon to the next neurons. That is what is the transfer of data, okay, transfer of the data from one neuron to other neuron. Axon endings almost touch the dendrites or cell body to the next neuron, and this is done by synapses. So, that is what actually happens in a typical processing elements. This is what is shown. So, for a single neuron, this is what is done. Okay, you can see that very clearly shown here. This is how the single neuron operates. You have x1, x2, x3, x4, x5 as the inputs, w1 to w5 as the weights. You sum it over, multiply each weights with x1, w1 x1 plus w2 x2 plus w3 x3 plus w4 x4 plus w5 x5. You add it up here, and then you have something here. You do some processing here. This is called transfer functions, and then you get a output. That is what is the how the basic INN networks works. Okay, you can see here, this is shown here. So, you have inputs x1 to xm, weights. What you have done? You have added together, and then you have a processing here done here somewhere there. That is what is the transfer function I am talking about it, okay, or activation functions. What are these? How do they behave? So, let us talk about a little more there. Again, same thing is shown here. So, there are a lot of questions, why you are adding weights, why they are multiplied, and why you are using activation functions, and finally, what you are doing at step 4. Okay. Step 1, step 2, step 3, step 4 we discussed in the last lecture. Well, in order to understand that, we have to first go to what is called perceptron. Perceptron is something which was discovered by Frank Rosenblatt in Cornell in USA. It is nothing but a simple binary classification algorithm. It allows you to divide the input data into two parts, yes or no, that is y or n. So, unlike many classification algorithms, perception is always modeled as a basic unit of human brain. So, neuron has the unparalleled ability to learn and solve a complex problem. That is why Frank assumed perception like a neuron. So, it should be like a model like a basic unit of human brain, that is a neuron. That is what is idea, and but it gives you inputs like a 0 and 1 or yes or no. This is what is you have to remember. But partially, what is a perception? It is a simple learning machine. It is not a difficult learning machine. It can take few inputs, each of which will have a weight. Why you are using weights? Very clear here, because it tells you how significantly important that particular input is. If suppose let us say I have yield strength of a material, I know yield strength of the material depends on grain size, depends on the phase, depends on the microstructure, depends on chemistry, but which one is playing more important role than the others? That can be only judged if you use weights. Okay, if you put specific weight on grain size, specific weight on the microstructure features, specific weight on the chemistry, specific weights on the composition. So, therefore, that will dictate or signify which is less important, which is more important. And finally, perceptron generates an output which is y or n. But you know, when these perceptrons are combined, then only it forms an artificial neural network. Remember this. So, basic unit is a perceptron. So, NN in principle can answer any question, any question, any different question, when you have enough training data and good computing power, okay, or computational power, then you can do that. And that is why ANN requires significantly high computational power and also time, but it can solve any difficult complex problems. So, in material science there are many complex problems exist, correlation between structure and property, correlation between processing and properties, they are very complex. I have discussed about it. ANN actually works very nicely. So, what is then, so that is about perceptron, right, you have understood. Now, what is multilayer? Multilayer perceptron is a perceptron which is basically teamed up with many other perceptrons. But how they are done? They are stacked in several layers, like here you have input, hidden, output, right. So, hidden there are many layers possible. I have shown only one layer, you can have hundreds of layers. So, they are called multi-layer perceptrons, and each perceptron, the first layer or the left, that is what is this one left on my left side, you can see it is basically called input layer, and it sends output to the perceptron to the second layer, that is the hidden layer, okay, it is written here hidden, you can see here, and all perceptron second layer send output to the final layer to the right. Here I am showing 3 layers only, that is why. So, input layer giving information or giving outputs to the hidden layer giving output layer, okay, that is what. But you can have as many as hidden layers possible, it is just like a huge networks. So, you are hope so you understand what is perceptrons and what is multi-layer perceptron, okay. So, I can go back in. So, perceptron is nothing but a simple machine learning tool, it gives decisions in terms of 0 and 1. But there is a difference between multi-layer perceptron and neural network. The difference is that decision functions is a step function here and output is a binary 0 and 1 in a multi-layer perceptions. Okay. In NN that evolves basically from this multi-layer perceptrons only, other activation function can be used. Not only this classical decision step functions, it can other activation function can be used. We have not yet discussed about little bit about activation function, we will talk about it, give you some examples also, and this results in outputs of real values. It can be between 0, 1 or -1 to 1 or even normalized or even some other values. Okay. So, that is the difference, and it also allows the neural network also allows the probability based predictions, a classification of item into multiple levels, that is also possible. So, this is a very simple thin line between multi-layer perceptron network and the neural network. Okay. But the major difference is I find is this decision making function is a step function in multi-layer perceptions of MLPs, and then this is can be any other activation functions, and therefore, it can give you other real values, not only 0 and 1 other real values are possible. So, that is what is shown here, a multi-layer perception. Okay. As you see here, you have some kind of weights which is 0, W0, then x1, x2, x3 or x till xn, which are several weights, they sum it over. So, input values perceptron take the real values as input, and then these are weighted and with some bias, okay, it will be added some bias. So, what is this? So, basically you write, let me see, I think earlier I have given you something. So, Aij I wrote in the last lecture, summation I going to 1 to n and wij superscript 1 xi plus wj0 1. So, remember the superscript 1 stands for first layer and j can vary from 1 to m, 1, 2, 3 n, right, m. So, this wij are weights, wj0 is bias. What is bias? Basically, bias is nothing but a quantity added to make sure if there is a small change in the input variables, then what can happen? That is what it is. So, bias weights is added and multiplied by constant equal to 1. That is what you see, W0 is multiplied by 1. So, you can think about it, both are actually multiplied by weights. Here is multiplied by specific weights wij, here that is multiplied by 1. And then finally, you get a weighted sum. After that, in multilayer perception, you apply step function. So, one of the example of step function, let me see, is what? Step function will be looking like a 1 by 1 minus exponential. Where is that? I wrote somewhere that function is very important function. 1 by 1 minus is one of the step function is 1 by exponential z minus z. That is the step function. This function will look like this. Okay, if you plot as a function of z. So, this is f z. This is step function. This is used for medical diagnosis, and but you can use other kinds of activation functions also. So, how does it learn? It takes inputs, as you see here, multiplies them by some weights and computes their sum, and then add a bias factor. Bias factor will be multiplied by 1. Feed this sum to some activation functions. It can be step function, it can be another activation functions. Functions can be anything actually, but that is why it can solve all kinds of complex problems, and that gives the output of the perceptron. So, one layer output, this will be fed to the next layer, again same thing will be done. So, if I have to discuss in very generic manner, let us take small steps. Steps 1, which takes the inputs, multiplies them with the weights and compute the sum. Why it is important? Weights, as I said, allow the perceptron to evaluate the relative importance of each of the inputs, relative importance of each of the inputs, because you are providing inputs, which one is more important than which other one. And this NN algorithm is learned by discovering better and better weights that results in more accurate predictions. How does it do? Well, there are several algorithms used to fine tune the weights. Most important one is what is known as a back propagations. You will see that back propagations network, back propagation things, hear it in books or something, because you have to adjust the weights or tune the weights rather. It is very nice word, it is called fine tune the weights. Okay. So, what is this? It is basically algorithm which allow you to perform the backward pass. In football, sometimes you have backward pass, right. So, players sometimes will take the ball, instead of sending to the front, they will put the backward pass. Okay, that allows them to think and tune what can happen when they are attacking, when they are going on an attack, right, to score a goal. That is exactly same thing. Backpropagation performs iterative backward passes many times, give and take backward passes. You will see that in football matches this happens nicely. They play among themselves so that the other team gets confused, and then finally they go for the attack. So, here it is exactly same thing. You have to have a successful solution or the less or better accuracy. Backpropagation performs the iterative backward passes which can attempt to minimize the loss. Or what is loss? It is nothing but difference between, that is what is error actually, loss is error, difference between the known correct predictions and the actual model predictions. That is what is that. So, each backward pass, the weights move towards an optimum that minimizes these loss function or error functions. We will talk about error function, that is better. This is because in the next I will talk about error functions, how it does it behave. So, that is very important, because you understand weights are very important. Then bias. Why do you add bias? Basically, it is a technical steps that makes it possible to move the activation curve up and down, left and right on the number graph. Okay, you understand that? It has nothing to do with weights, it is to do with activation function that can curve up and down, left and right the number curve, and it also allows you to fine tune the numerical output of the perceptrons, perceptron, it allows you. So, that is why bias has to be added, and bias can be changed also. Then what happens, you have added bias, you have added the weights, then comes the activation functions, and this feeds the sum through the activation function. The feeds means they add the x0, x1 w1, x2 w2 plus the bias, this is a feed. This feeds gives to the activation function. Activation function maps the input values to the required output values. So, you have a choice to select the activation function in ANN or MLP. So, for example, input values could be between 1 and 100, output can be 0 and 1. Activation function also helps a perceptron to learn when it is a part of multi-layer perceptrons. So, that is what it does. Certain properties of activation function especially is non-linear nature and make it complex. You can have various kinds of activation function, I told you about one, this is the activation function. Then you have activation function like this, 1 plus sin z, or many other activation function possible, 1 by 1 plus sin z, the exponential one the best one. So, when we will discuss about the TS will discuss about how solving the problem, they will discuss, show you what are the different activation functions used. And output is nothing but a classification decisions. So, for perceptron it will be 0 and 1, for neural network it can be any other values. So, not only that, we also use the several transformations, right, and these transformations are used for deep neural networks, and you have to hold it back because we have a separate set of lectures for deep learning, and ANN is also can be used in deep learning methods, and MLP is has all these features. I have already discussed about back propagations, then you have hyperparameter tunings, and there are some advanced structures possible also, which also require to be understood. So, these aspects we will discuss when you talk about deep learning methods. So, deep learning is something which we will be using after the machine learning, which we will be discussing. There we will talk about deep learning, and deep learning we will discuss these aspects. So, last thing I will talk about is the topology of neural network. You can have different topologies like complexly connected, you can see here this is a complexly connected. You can also have complex connected means they are like a connected to everything, is connected to everything, and they can also have feed forward, a cyclic. You can see that this is a feed forward like this, how it is that, and you can also have recurrent like feedback connections, which is more common. These feedback connections are more common in the literature. So, feed forward versus recurrent network, feed forward has no loops, and basically you have hidden input to hidden layer to output, but recurrent ones has feedback, and that is better actually, that can solve much complex problem. Feedback can be negative or positive also, depending on feedback the system can change the calculations. You can also have continuous versus spiking networks. Continuous network model can spike, can mean spike rate or firing rate. So, spikes are nothing but integration over time, right, and supervised learning is what is used. We are talking about that, but neural networks can also use unsupervised learning also. So, that is about the neural network. In the next part of the lecture, we will talk mostly about the KNN, and we will talk a little more something about the errors in the artificial neural network. So, let us stop here, we will come back to the next part of this lecture.